So today I will talk about the third part of what we call spherical polar coordinates, and here I will talk about unit vectors in spherical polar coordinate system. So in case of Cartesian coordinates, I cap, j cap and k cap, these are the Cartesian coordinate unit vectors, and the very interesting thing will happen with these coordinates, that say it is x-axis and say it is y-axis and say it is z-axis. Then I cap is along x-axis and the j cap is along y-axis and the k cap is along z-axis. Polar coordinates and their unit vectors. A very interesting thing will happens to those. So what is that? So for the spherical polar coordinates, system, here theta cap, sorry, here r cap, theta cap and phi cap, or sometimes they are represented by er cap, e theta cap or e phi cap. They represents the unit vectors. Unit vector representation. This is the unit vector representation in spherical polar coordinate system. Right? And what is r cap? In which direction they have to be taken? Because in the earlier they are taken along x, y and the z, right? But in case of spherical polar coordinate system, in which direction we have to take these? Let us draw a coordinate system and say the particle is here somewhere and it is represented by like this. So this is a particle is placed at point P, and this is the, at this point, this is the direction of the r vector. So let us call it as r cap. Means, so what is r cap? So r cap is along increasing direction of r at that time, right? At that time at which I am looking at the particle, and say it is making an angle theta with the x-axis. So it is x direction, sorry, z-axis. So it is z-axis, it is x-axis and it is y-axis. So it is making an angle theta. So theta cap is basically, say if I draw a at this point, so it will go like this. So it will go like this curve, and if I draw a tangent to it, so tangent point at this point is represented by this one. So this is the theta. So that means it is along the increasing direction of theta. So theta cap is along increasing direction of theta. and say this is P point, it is pointing towards here, and theta is increasing like a curve. So that means if I draw a tangent to it, so that means r cap and theta cap, they are perpendicular to each other. This is the one way to look at it. Pictorially, I have to look at it. Then, so theta cap is this. Let us now have a look at it. So that means if I draw a perpendicular from this point to xy plane, so this is a perpendicular I have drawn from this to this. So that means then this is, say it is the rho, and say this angle is phi. So it is going like this. So that means if I draw this one, then this is the phi cap, means the direction in which phi is changing. So after some time, say if particle will be somewhere here, say particle will be somewhere here, then this one, and here if I draw a perpendicular from here to here, then it will go like this, right? This angle is phi, so phi direction will go like this. So this is a way that how we can look at the particle. So r is changing over the surface, phi is changing, and theta cap is also changing. So what is theta cap, phi cap, and it is along increasing direction of phi, right? So that means if I do like this, then this direction is also known as phi cap. So if I take it parallel, bring from here to here, then it is also phi cap. So it is the increasing direction of this one, and say it is like this, theta cap is this way. So it is parallel to this point, and at this point it is parallel to this point. So that means this and this both will represent theta cap, and this direction with it will represent phi cap, right? So now another thing which we have to do, that is to represent r theta and phi, r cap, theta cap, and phi cap in terms of I cap, j cap, and phi cap. So let us go to it. Again redraw a diagram, or let me go back to the another diagram. First of all, let me do one thing. R vector is basically is to find out this. Let us look at r vector. R vector is represented by r cap multiplied by its magnitude. So that means this r cap is basically r vector divided by its magnitude. It will represent what? It will represent r cap. So what is r vector in terms of spherical polar coordinates? So it's r sine theta cos phi I cap plus, because we know that r is xi cap, yj cap, and zk cap. So I just putting the values of x, y, and z here. So it is r sine theta cos phi I cap plus r sine theta sine phi j cap, and plus r cos of theta k cap, and whole divided by r. So it comes out to be sine theta cos phi I cap plus sine theta sine phi j cap plus cos of theta k cap. So this is the unit vector r cap in terms of I cap, j cap, and k cap. So let us now look at the theta cap. So this is all about r cap. Now let us try to look at the theta cap. So what is theta cap? say it is r, and r cap is along this direction as I discussed, and theta is along this direction. So that means it is like this, it is going like this. So that means this is theta cap, and this theta cap is perpendicular to r cap. So particle is suppose moving from here to here, so that means theta cap leads r, theta cap leads r cap. So if theta cap leads r cap and the theta is perpendicular to r cap, so that means there is an angle between them is pi by 2. So therefore, if I do one thing, that if I simply replace, if in r cap I replace theta by theta plus pi by 2, I will get theta cap. So that means this theta cap is simply sine theta cos phi I cap plus sine theta sine phi plus j cap and plus cos of theta k cap, and I simply replace this theta with the theta plus pi by 2, theta plus pi by 2. So I can write down it as a cos of theta cos of phi I cap plus cos of theta sine phi j cap plus, sorry, not plus, but it will become a minus, it is sine of theta k cap. Basically sine theta plus pi by 2 is cos theta because it is in the second quadrant, and at pi by 2 t ratio will change, similar happens to it, and here it is also in the second quadrant, right? So these all are in the second quadrant. So using that concept I write down it like this. So it is a cos theta cos phi I cap cos theta sine phi j cap minus sine theta k cap. So let us now look at phi cap. So it is like this, it is rho and it is making an angle phi. So phi is this one, phi is basically this way. So here theta cap and phi cap both are perpendicular, both are perpendicular to each other, right? And what is this rho? As I did in the earlier lecture, so for phi cap let us proceed. So as I did in the earlier lecture, that this rho, these both are perpendicular, but I'm not using this concept here. So here rho vector, as I described, it is the r sine of theta, right? It is the rho r sine theta, and this rho vector has two components. One component is along y-axis and another component is along x-axis. So it is rho cos phi, and this component is rho sine of phi. So that means, what should I do? I can write down rho vector as rho cos phi I cap plus rho sine of phi j cap. One is along x-axis and another is along y-axis. And what is rho cap? Rho cap I have to be written as the rho vector divided by rho. So it is cos of phi I cap and plus sine of phi j cap. That's what I am getting here. Right? But if I try to look at, this is the direction of rho vector and this is the direction of phi cap, so both are perpendicular to each other, and phi is leading rho cap. So that means this, rather than this looking at it, I have to look at the rho vector or the unit vector rho and the phi cap, both are perpendicular, and as I did here, so that means rho is, this phi cap is leading phi cap leads rho cap. So it's a very simple trick I'm using. So what should I do? I simply, in the rho cap, I change phi with the phi plus pi by 2. Phi with phi plus pi by 2. And I will get the expression for what? I will get the expression for phi cap. So that means this phi cap is equal to cos of phi plus pi by 2 I cap plus sine of phi plus pi by 2 and the j cap. So I simply write down is the minus sine phi plus cos of phi j cap. So let me summarize these results here now. So what are the results which I am getting? So r cap, it can be written as sine theta cos phi I cap plus sine theta sine phi j cap plus cos of theta k cap. And what is theta cap? Theta cap is equal to cos of theta and cos of phi I cap cos of theta sine phi j cap sorry, it will become minus sine theta k cap. And what is phi cap? Phi cap is equal to cos phi I cap plus sine of phi j cap, right? So here these things are common, right? And another very interesting thing is happening here, that here as particle moves from p point to another p prime point, say this is another p prime point, so then r theta and phi cap, they are changing, they are not fixed as we have seen in case of Cartesian coordinates. So that's all for this lecture.